Hello everyone. So we all know what are permutations of numbers. There are some rearrangement of numbers from 1 to n for a standard definition. But what are cycles in a permutation? We are going to learn it along with the short problem solving, and this is going to be really helpful in your future because this method of handling permutation allows you to go far beyond problems in usual and routine mathematics. So let's get started. So permutation is nothing but rearrangement of the numbers 1 to n in some way. So we call the number in the first place to be sigma of 1, second place to be sigma of 2, sigma of 3, and so on till sigma of n, where sigma is a function which is used to represent the permutation. An example could be numbers from 1 to 5 permuted as 3, 2, 1, 4, 5. But here, what is a cycle? So, here is one way to realize this permutation. For example, here 3, the number 3 in the actual permutation is in the place of 1. And let's think about the number 1. Number 1 is in the place of 3. So draw an arrow from 1 to 3. And 2, 4, 5 are in its own place. They are regarded as fixed points in permutation. But what we have constructed are precisely the cycles in the permutation. For example, this is a 2 cycle and the others are 1 cycle. Let me give you one more example. Let's take 1, 3, 4, 5, 2. And let's try to derive its cycle. So 1 is in the place of 1. Whereas if you take the number 3, it is in the place of 2. And again, think about the number 2. It is in the place of 5. So draw an arrow pointing to 5 from 2. And 5 is in the place of 4. So draw an arrow pointing to 4, and then 4 is in the place of 3. Thereby we complete the cycle. So this permutation contains one 3 cycle, namely 3, 2, 5, 4 in that order. So here 3, 2, 5, 4 means number 3 occupies the place 2, number 2 occupies the place 5, and number 5 on 4, and number 4 on 3. And it just repeats. So, this is a 4 cycle. And this is a 1 cycle, which can be represented as 1. So thus, this permutation, the entire permutation 1, 3, 4, 5, 2, is essentially the 1 cycle 1 combined with the 4 cycle 3, 2, 5. So we then regard the permutation with its cycle representation. One can as well notice that every cycle representation is unique for a given permutation. You can't have 2 cycles representation. It is due to the same logic. It would be consistent with whatever way you do. It doesn't matter if you start the cycle with 4 or 5 or 2 or 3. Anyways, you are going to end up with the same cycle. Maybe just your starting point is different, but you will end up with the same point. So if you start with 2, you will have 2, 5, 4, 3, which is essentially the same. And it also turns out that every cycle permutation represents the actual permutation of the numbers. For example, let's take a cycle permutation as follows. So I'm taking some random. Let's take 1, 2, 3, 4, 5. And let's see what this permutation is. Let's see what it represents in permutation. The number 1 is in the place of 2. The number 2 is in the place of 3. The number 3 is in the place of 1. So remember, this is how you need to decode cycle representation. And 4 is in the place of 5. 5 is in the place of 4. So this means first write the positions for the numbers from 1 to 5 and which number is in the place 1? The number 3 is in the place 1 because 3 goes to 1 and 1 goes to 2. So 1 is in the place of 2. And the number 2 is in the place of, and similarly 4 is in the place of 5 and 5 is in the place of 4. So 3, 1, 2, 5, 4 is the permutation represented by the cycle 1, 2, 3, 4, 5. So this is a one-to-one correspondence between the set of all permutations and the set of all cycle representations. You may consider 3 cycles, 4 cycles, 5 cycles, or even 1 cycles. For example, if you consider it as identity permutation, it is just all 1 cycles. And as a convention, we sometimes neglect or ignore the 1 cycles, but you may also not follow that. It's better to represent it initially. Thus, we get the number of permutation, which is actually n factorial, equals number of ways to represent numbers from 1 to n in cycles, or to be more precise, disjoint cycles. Why are they disjoint? It is disjoint for a trivial reason, because once that number is considered, then after the cycle ends, we will never be going to that position because that number is eradicated from that permutation. So only remaining numbers exist and they do matter. So we have no possibility to get back to that number because we got back to it from some other position which is already present in that cycle. For example, in 4 and 5, we cannot have a 3 in this cycle because we already had 3 and there is a number which is present in the position 3, which is 1. So thus you cannot again get a 3 here, which implies the cycles are disjoint. So let's quickly solve a problem related to this. Find the number of permutations of the numbers from 1 to n that has a given R cycle in. So again, R cycle is nothing but x1 goes to the position x2 and the number x2 goes to the position x3 and so on till we have xr going back to x1. And this is what we call as R cycle because it is R in length. Let's say this particular R cycle is given to us. For an example, if you are given a 3 cycle, it may look like this: 2, 3, and 5. So how many permutations of the number 1 to n exist containing this? It is simple. Remember that this R cycle fills up R position automatically. For example, if you consider the position x1, I have the number xr going to the position x1. And in the position x2, I have the number x1 going into it. And similarly, in the position xk, I have the number xk minus 1 going to it. So all these numbers or the positions from x1 to xr are now filled up. There is no need to consider them as positions and as well as their values. But we have remaining n minus r numbers and we will have n minus r blanks. So it is just n minus r factorial ways to arrange them in those n minus r blanks because the numbers are distinct and each number can occupy exactly one blank. So it is n minus r factorial number of permutation that has this given R cycle in it. So there are a lot more applications of it which you will learn in your future, and I hope you enjoyed this. So for students who are more curious about it, you can learn the concept behind Stirling number of first kind, and this is exactly used in it to find the summation of all Stirling numbers of the first kind. And this is also used in group theory. It has a crucial part to play and it helps in analysis of group elements. So I hope this video will be useful for you. See you all in the next video. Thank you.